So like everyone knows, I'm Yemi, and basically a little bit about me. I'm a software engineer because I think the team is like a bit bigger now, right? They are like newer people. Yeah. So that's why I'm talking about myself. So um I'm a backend engineer. Uh, and I used to work at Kotankush for about 2 years with everybody, almost everybody in the room. And yeah, anyways. So I also do like some street and nature photography now. And you can follow me on Instagram. So like about my team that I currently work. So now I work at Delivery Hero. I work at like a team called Pandora, and we are like around 25 backend engineers or thereabouts. Sorry, I'm really backend biased, so I just forgot the numbers for backend. And and we use like so we are organized in like small teams, small cross-functional teams, and so I'm in the team that is responsible for calculation and other placements. And yeah, so that's me. It's, to be honest, it's really like a tough one because it's just telling you guys about my learnings and also like uh, some things that I've seen that are actually pretty similar to what we do at Kota and Kush, and like some other like little engineering tips that might be of help. So this is me with my team uh, on a random day. Okay, so right into it. So one of the first lessons that I think that I learned is that like data is king, and uh, like and when you say data is king, like I know that it's a very like common uh, word or phrase that people use, but I think the way the sense in which I'm talking about it is that not just in terms of the business, but also like in terms of like engineering. For example, like you could imagine like on a particular day you get to work and you get a report or something like this that you have some customers that are not able to order. The kind of sort of urgency that will present to the problem is really dependent on like the percentage of orders or that are affected at the moment. So and to have that, it means that like while you're building your application, you have to already like build like some level of uh, monitoring or observability that you already have to put in place. So so that's it about data. Like it's also like applicable in almost like every sense of things across like the spectrum of software development. So I think one of the huge lessons for me is that software is not just like data is not just for the business. It's also like very important in engineering because like to give a very practical example, I was working on a particular integration like a month or thereabout ago, and like so we were having some failures with this integration, and we were just having like people like telling us that this thing like you have lots of failures, but until we were able to put a number to it, like everybody was just like, you have lots of failures, you have lots of failures. But if you're able to put a number to it that is just like this percentage and it's localized to this particular country, that was when like it began to make sense. It began to make sense that like, okay, the integration is working fine, and we just needed to fix like these little issues that we have. So I think the lesson here is to as engineers, or like to improve like our like your engineering processes, you have to always like find ways of measuring um, like the KPIs, so to speak. It doesn't really have to be business KPIs. key performance indexes that maybe, for example, if we are, for example, working on testing, we should be able to say this percentage of our applications have testing and this percentage don't have testing. So just using like that kind of data to make decisions. Yeah. So I think the second big learning for me is that no knowledge is waste. So there are like lots of things um, that I found out that although it felt like at some point I learned to do them, but I didn't see the applicability or a ways to apply them. Let me say ways to apply them at the time I was learning. So, uh, say for example, learning about distributed systems. Um, there was really no uh, like opportunity to apply that because um, we didn't have that kind of environment. But really, like no, I don't feel like any opportunity that we get to learn something, maybe learn a little bit more about what you are doing, or learn a little bit more about the basics, even the basics of what you are doing is a waste. And also, like there have been points where I've met people that are into design thinking, for example, and that was the way I was able to start a conversation with them because at some point in time we had like some design thinking training at Quarter and Coach. So really like believe that like no knowledge is a waste, and so it is important to like always be open to learning and always like be like ready to learn, even if though it feels like it might not be totally useful in the moment, or you only use like a little percentage of it in the moment. Then it's always important to be open to learn. Yeah. So, so there are full of technologies that um, I would say like are not totally new to me because they're not totally new, but also like that stuff that I now use extensively, and I believe that they help a lot to like ease make easy the process of engineering itself. So like all of us, or like almost all of you guys are like used to like Docker. I think I learned that some of your applications are now even like Dockerized. So I see it as like it's more or less like pretty important to go in this direction because it doesn't just help like new joiners or new people when they are trying to onboard, but also even in production, depending on what kind of uh, infrastructure you are going to set up in production, it's also like very useful and efficient. Kubernetes is on more of a like bigger scale, like when you have like thousands of Docker containers and you need to manage them, then you start getting into world of Kubernetes and every other thing that comes with it. Then also like I think one of the things that I think was more or less like a mind shift for me was the way how important logging is. Uh, can you guys hear me?
Yes, Yemi.
Okay, looks like
Yes,
everybody
yes.
went quiet. Okay, anyway.
I'm paying attention.
Okay, like one of the things that was like that was very more or less like a mindset shift for me was like the way like logging became is important and how logging is used. For example, like to track down like some issues on production maybe, or to even like get some relevant business related data. Sometimes we would just more or less like analyze our logs and get this information directly from the logs. So I think like one of the things that really help to enhance like the performance of applications in production is having a proper login infrastructure or a proper way of logging, and like with your logs, you can do you can then go from there and do like some form of alerting or set up some um, conditions that would sort of let you know when something is going wrong, or and stuff like that. So I think what really changed for me was more or less like logs are not like throwaway. Uh, logs are not log for an application is not a throwaway part of the application. So you should already like build it when you're building your application. You should already have like the login flow in place, like like how you're going to like what are the debug logs that are going to log, and what do you do when there is an error, and what do you do when some other component is failing, and all of this. So that's also is important. And also like I started like using like doing like lots of Golang, and it's a very interesting language that I think everybody should check out. Or if you don't check it out, but just check out like one of the new modern languages, Swift, Kotlin, Golang, like depending on what you're doing, because maybe the mobile guys will not really learn Golang, or maybe check out Swift or Kotlin, or even for the backend guys, check out Kotlin and some like just like new paradigms that will be really interesting for like everybody to know or learn. Yeah, even if you don't need it right now. Yeah, so a little bit of so I just like put like all of these tips together. Yeah, that's some of the things that like I now think about, like when going through the process of development or designing, or designing something. So I think the first thing is to like think resilience. So it's like out of the box, like when you start learning programming, like you would like, and maybe you're doing like a tutorial or something, you say like, okay, there's an error could happen here, but we can just discard it. We don't really care, we just care about what happens when everything is right. Yeah, but that can really like cause a lot of problems if you don't think about it like beforehand. For example, say you're connecting to a third-party service, like maybe let's say Twilio, or you are talking to maybe even an API from the mobile point of view, or an API from the front end point of view. Yeah, you should already think beforehand what could go wrong. Is it possible for like the service that you are trying to talk to is down? Is it possible that is it possible that for some reason you are getting like some unexpected error? So what are the steps that you take, or what kind of mitigation would you take, like if that kind of stuff happens? So it's important to already think about this beforehand, even while you are designing your application, and put checks in place to be able to uh, mitigate against like this kind of stuff. So resiliency is like it's a big topic on its own, and there are like different approaches that you can use to handle or to ensure that your application is very resilient. Like a good example is using a circuit breaker. Um, so you can like check up on that, like just like it's important that your application is resilient. Yeah, so I already mentioned the second point, that run everything in containers if possible. Uh, like it's just like it's simple for you. Like you don't have to care about like the underlying infrastructure on the machine that you're running on. Like all of that. You just have to really care about what is going on in your container, and you can put containers on top of each other and stuff like that. Especially like this is more towards like the back end side of things. Yeah. Then I think another important point that I also learned along the line is to research, like try to avoid like brute force designs as much as possible. Like I think the hallmark of like a good engineer is someone that tries to see, okay, what approaches, what are the recommended approaches to this solution first, and let's try and compare, okay, 1, 2, 3 approaches, and which one really fits our use case right now. Not just like the first brute force approach that comes to mind. Like, I think it's important to research to try and avoid brute force designs as much as possible. Then I think this is more on the soft side of things, is to be a contributor. Um, like I think that is important, like almost anywhere, like um, although you'll find that there are like cultures that don't by default support ownership or being a contributor, but like I feel that if you develop this kind of mindset of contributing, like wherever you at whatever level you are, like not just taking like the back seat, but contributing and taking an ownership mindset, you'll find out that wherever you get to, or even at the place where you are, you will start improving, or you'll find yourself improving. Yeah. And I think the next point is like pretty straightforward, like is to pay attention to details. um I think when I first started at Pandora, they were like,
Hi, Yemi.
yes,
So I know we can ask questions later, but I just wanted you to emphasize this brute force designs
okay,
and like give examples or be a bit more specific. Just
okay,
we're all on the same page and we have a common understanding.
yes, okay. So to be on the same page, mm, mm, all right. So like let's say, for example, that we want to uh, send an email to a customer. We want to send an email to a customer, and a very important email, for example, and we decide to just like send this email, like after the customer logs in, let's say, and we need to send an important email to the customer about maybe what will be important after. So let's say we want to send an email to them about like the next steps they need to take, and there's no other way that they can take this next step. And we decide to like just send this email. Like we just like at the point of login, we just send this email. We don't, and we just say, okay, so what we're going to do is to just, after you're logged in, we just send this email and that's it. Like, but there are like approaches that you can also use that will ensure that at some point like this, the email gets to the customer. So that's just tying back to resiliency that I was mentioning. Like, it's probably better for us to queue up that email somewhere, and then in the background then try and process this email, and then if there's a failure, we can then retry and all of that. And there are also possibly other several approaches and other decisions we will try to make along the lines. So maybe how do we template the email, for example, or say how do we send multiple emails at once. So like it's always easy to say, okay, for example, if we are talking about sending multiple emails at once, we can just say, okay, we'll put everything in it. We can put everything in a loop. And this example is like pretty basic. Like we put everything in a loop and try to send this email. But you find out that as time goes on, you begin to experience like failures due to this like force approach to solving this particular problem. So like just taking like a little step further to implement like the best solution for the use case. And when I'm saying the use case, it means that like in the constraints of like what your infrastructure affords you. So maybe you don't really have you don't have the luxury of getting a very high you don't have the luxury of maybe getting a proper queuing system. So maybe like something like RabbitMQ or something like AWS SQS. If you don't have that luxury, then there are also other approaches that you might be able to apply that fits the use case and fits the constraint, like just doing the best thing for the situation. That is what I was sort of referring to. Yeah. So Talks, does that help?
It helps. Thank you.
Yeah.
I don't know if you guys are happy with that explanation. You can ask afterwards or now if you want.
Yeah. Okay. Yeah. So I think the next stuff to talk about also is to understand like architecture, or let's just say architectural approaches. And like this is not just for like the back end guys. I know that there are lots of architectures that are also applied on mobile side of things, although that's more or less like on a code level. So like, but it's important to, and when I say architecture, is more or less like looking at like your applications at the higher level. So say maybe we are working on, maybe as a person, the only thing you're working on is you're working on maybe the backend service, for example, maybe service that serves ads, let's say, maybe. And it's important to understand like how your own software or your own service is interacting with other services and what the big picture is like. Because like you might be in a situation where you now need to think about 20 different services and how they interact with each other, you know, and like having an understanding of applications at this sort of high level might help you to be able to like navigate like this kind of environment. So in terms of that, I know that for every different function, mobile backend, mobile front end, there are different ways you can learn about architecture. But usually, to be honest, it's really about more or less like reading. Like it's when you start reading about architecture that you start getting more knowledge about uh, like what really happens on a high level. So for maybe like the backend guys, for example, like you should not only like know about like the MVC architecture, you should also try and research other things like maybe event-driven architecture and see how you can even apply like them on like right now. And sorry, mobile guys, I cannot really tell, but I know like there are also different architectures that you can use, and same goes for the front end guys. So it's not really just about like solving the problem, but also like following like the best practices that will ensure that whatever you are building right now is maintainable, and it's maintainable and malleable like over the course of time. Yeah, so that's what I would say. Like architecture, like studying or learning about architecture. I think the whole summary on this point would be to just study, but also like try and make a study at some point also focused on architecture. Yeah, I think so. The next point is more of a like engineering wide thing, is to be automation first. Like if you find like tasks or things that you figure out that you do manually, like every time you should try and automate that, because that helps you, it gives you more leverage, and you are able to do other things that are more important. You find time to study, you find time to do things that are now more interesting, or even to research. Yeah, I think that's that. And the last point I would say is like to test all things. Like um, so there are days like where I I don't know. Like I just maybe developed something and I didn't test it, and it found its way to production, and then something started happening in production. Yeah. From that point on, I just like learned this mantra about like testing all things. Like apart from maybe writing like your unit test or integration test, also like take time to, if there's some manual testing like needed, like take time to, as a dev, like take time to also uh like do this testing, even if it's just with a few scenarios. But it's also important to do that, and also like to take like testing very like more seriously, because that's really what like helps the health of your application. You see what I mean? Like it's like there's no way you can really say whether the code works. Like if you don't test it, like if you don't like maybe write a test for it, like you cannot really say. Like it's more like you're just flying blind. So you cannot really say whether it will work given the use cases that you are building it for, or if it would not work. And also, like, of course, testing gives you also other advantages. Like you can easily modify like the code base and easily refactor it. You can ensure that you're using like uh, some best practices, because if you don't do it, then your code is not testable. Yeah. So uh, to be honest, these are just like the few tips that I have uh, right now. And I think like a bigger part of this discussion would come more like when you guys ask like questions, because as you know, I don't talk much. So you ask, like, if you have questions, like it will, like, I'll be able to then answer your questions. And because I also need to understand like what you are doing and how